Okay, moving on to another kind of category of events. We talked yesterday about mutually exclusive events that cannot happen at the same time. Another category is independent events, and they can happen at the same time. For example, if I have a die and a coin, and I want to know the probability that when I roll the die, if I roll the die, I get a 5, and at the same time, or immediately after I toss the coin and get a heads, well, I can roll a die and get a 5, and I can toss the coin and get a heads. It could happen at the same time. So they're not mutually exclusive. Then what happens to the die, or the outcome of the die, does not affect what happens with the coin. And that's the definition of independent events. There are two events. Two events are independent if the outcome of one event does not affect the outcome of the other. Now there are some gray areas, especially in the area of athletics, and I'll give some examples of that. Because sometimes it becomes psychological, and if you're successful, you tend to have a higher probability of success, or if you fail, your odds of, like you're shooting free throws, you might be a 50% shooter, but if you miss 4 in a row, the case could be made that you're not really, your probability of making the next one's not 50%, it might be a little lower because of loss of confidence. But we kind of ignore those factors in the mathematical realm. If two events are independent, and you know they're separate probabilities, you can just multiply them together to find out the probability that they'll happen at the same time, because they can happen at the same time. So you know, if I wanted to get a 2, so when I roll the die, the probability of a 2, and I want to get a heads on the coin toss, I can take the probability of getting a 2, which we know is there's 1 out of 6 ways to get a 2. So it would be 1 out of 6, and the probability of getting heads is 1/2. And so the math I had to do is 1/6 times 1/2, which would be 1/12. So it's not really that complicated. You just have to know the probability of the separate events, and then multiply them together. And there can be more than 2 events, and athletics is a really great example. Suppose that you know over the course of a season you're playing baseball or softball, and you know that you reach base one way or the other by getting hit by the pitch, or reaching on an error, or stopping a base hit. You reach base 1 out of every 3 times that you bat. In this particular game, you're going to bat 5 times. And you're wondering, well, what's the probability that I reach base every single time? Well, that would be, the probability that you reach base every single time would be 1/3 times 1/3. The third time, the probability you reach base is 1/3. The fourth time you bat, the probability that you reach base is 1/3. And the fifth time you bat, the probability that you reach base is 1/3. So I didn't calculate this ahead of time, but it's going to be a pretty large number. 27 times 9, 180, I think it's 201. 1 out of 201. 81 times 3, no, 203. 3, oh, that's just wrong. 3 times 3 is 9, times 3 is 27, times 3 is 81, and 81 times 3, yep, it's 1 out of 243. So not really great odds or chance probability that you'll reach base 5 times in a row, but if you're an athlete and you play baseball or softball, you know that could happen. Or suppose you're shooting free throws, and you're pretty good, you may make half your free throws, and you're shooting a 3 from the field, and you get fouled, so you get your 3 shots. What's the probability that you make the first shot, and you make the second shot, we'll call that event B, and you make the third shot, we'll call that event C. What's the probability of A, B, and C? The probability of A is 1/2, because you're a 50% shooter. Probability of B is 1/2, 50% shooter, and probability of C is 1/2, you're a 50% shooter. And that would make 1 out of 8. I coached a volleyball team years ago, and you lead the game off with a coin toss to see who gets to serve first, and we lost that coin toss, I think, 8 times in a row. So to figure out the probability that happened, you actually do 1/2 to the 8th power, which is pretty slim. I think it's 1 out of 256. I'll calculate pretty quick. Yep, 1 out of 256, but it did happen. So strange things can occur. Why don't you do one other problem that's kind of more typical, and that involves weather forecasting. I think this is actually problem number 2, perhaps it is. And problem number 3 on page 145. So the forecast calls for a 30% chance of rain today. So there's a 3 out of 10 chance it'll rain today. But a larger likelihood of rain tomorrow, higher likelihood, 70% chance of rain tomorrow. So farmers might be asking the question, what's the probability that it rains both today and tomorrow? And you might make an argument that these events are not independent, that the weather tomorrow is affected by the weather today. But let's just make the assumption that that's not true. And these are separate, independent events, that what happens tomorrow is not affected by what happens today. So if we follow the formula, we'll say the probability of rain today and rain tomorrow, if we call this the probability of rain today and tomorrow, since they both start with a T, I have to use a little subscript there, would be the probability of today's event. I'm just going to just put up here 30%, which is 0.3, times 70%, which is 0.7, and that would be 0.21 or 21%. We'll see what happens here. All probabilities, if they're expressed as a percent, have to be less than 100%. And when you multiply 2 percents together, the product is always going to be smaller, a smaller number than either of these two. When you multiply 2 fractions together that are both less than 1, the product of the 2 fractions is always smaller than either of the two. First, when you do a half times a third, the product has to be less than a half and less than a third, because you're only taking half of a third if you look at it that way, or you're taking a third of a half if you want to turn it around. So the product has to be less than this and less than a half. Therefore, the likelihood of 2 events occurring together, or one right after the other, is always less than the probability of each separate event occurring. So there's going to be less than a 30% chance of rain both days. There's going to be less than a 30% chance of rain both days. That's how it works. If your probability of making free throws 50%, the likelihood of 2 in a row is less than 50%. So that's the lesson on independent events.